Write the major product of the following reaction, and the reaction is given by it is a bicyclic naphthalene type of system connected with the saturated aliphatic part, that is ethyl group, unsaturated aliphatic part ethylene group, followed by one ester group is present. This particular substance is subjected for the set of reactions like alkaline KMnO4 followed by heating conditions followed by H3O plus, that is acidic medium. Under these conditions, if this reaction is executed, alkaline KMnO4 followed by heating conditions converts all the saturated as well as unsaturated hydrocarbon portions connected with the benzene and the benzene like of systems are converted to corresponding carboxylic acid. Hence, this particular transformation is resulted as, so this particular benzene ring remains as it is, this particular benzene ring remains as it is as a result of first reaction. This particular portion is converted as potassium salt of carboxylate. This is potassium salt of carboxylate. This is also converted as potassium salt of carboxylate, and this particular ester remains as it is. Whatever ester group is present, that ester group remains as it is. This further on reaction with the second condition, that is H3O plus, all these potassium salts are getting replaced by the proton. It is converted to carboxylic acid. Here, due to that space issue, I am writing here the product is one first benzene ring remains as it is, second benzene ring remains as it is. This becomes carboxylic acid. This also becomes carboxylic acid, followed by this ester also undergoes hydrolysis and is converted as carboxylic acid. Thus, alkaline KMnO4 converts all the saturated aliphatic and the unsaturated aliphatic into carboxylic acids. This bottom portion, one carbon containing potassium salt of carboxylate. This top portion, one carbon containing potassium salt of carboxylate. Ester remains as it is. On hydrolysis, ester also under involves in cleavage, results into the formation of what? Acid. Thus, it results as, whereas there is some correction in this question, there is some CH2 in the middle. So therefore, here the first product consisting of under one carbon, whereas the second also carries with the same number of carbons. Hence, the final product of this transformation is three acid groups are associated with the naphthalene. One is CH2 followed by acid, remaining two are direct acids connected with the one of the benzene ring, other is with the CH2COOH. Another question, write the major product of the following transformation, and the reaction for the transformation is given by, here reaction conditions are provided for us, and it is consisting of, it is a benzene associated with, one is methoxy group, second one is nitro group connected to this, associated with a lengthy chain, and at the second carbon from one of the terminal, it is consisting of chlorine, and it is subjected for anhydrous aluminium chloride. Whereas anhydrous aluminium chloride is a Lewis acid, as being anhydrous aluminium chloride is a Lewis acid, it combines with the chlorine, the lone pairs present on the chlorine. As a result, this chlorine and the aluminium trichloride combination results into the formation of cation followed by what? AlCl4 minus. If we write the mechanism, yes, if you go for the mechanism, as we said, this is AlCl3. AlCl3 is having vacant orbitals because it is electron deficient, whereas chlorine is having lone pairs. The electron density present on the chlorine is given towards the vacant orbital present on the aluminium. As a result, this whole system cleaves from the alkyl chain as AlCl4 minus. Thus, it results as AlCl4 minus followed by the initial one as our cation. So, therefore, this benzene associated with methyl group associated with NO2 followed by whatever the remaining portion consisting 1, 2, that is followed by here cation formation takes place. This is our electrophile and this is our benzene system. Now this particular portion is acting as electrophile. That is inside the reaction itself. It is consisting of electrophile. Moreover, the reaction, where the reaction has to be occur, more electron density containing species, that is Electrophile acceptor is also present. Electrophile is also present as a part and part of the reaction. If we go for the final product, that is formation of the product, yes, to write the final product, if I number, this is 1 2 3 4 5 and the 6, whereas this particular group is plus Me group. This plus Me group is acting as ortho para directing group. This group is plus Me group, whereas this NO2 group is deactivating group. This is known as what? Minus Me group. Due to the presence of both plus Me as well as minus Me, plus Me dominates, plus Me nature dominates. As a result of presence of this plus Me group, as being it is ortho para positions are preferable for the attack. Whereas this ortho position will becomes very much crowded. Suppose if this is the place, if we consider, because here all four groups are present at one spot, makes benzene as more crowded part. So therefore we are preferring the para position. If I number from the para, this particular carbocation position is becoming sixth place. If I write, this is the sixth place. Now here, as electrophile, it makes a substitution over the benzene ring system. Further hydrogen elimination takes place, that is substitution of hydrogen in the place of hydrogen. This cation makes an attack. Thus final product results into the formation of two cycles. One is benzene 6-member ring, another one is 6-member normal system consisting of connectivities like methoxy group is present, followed by what? NO2 group is present. If we give the justification to the product formation of this corresponding reaction, if we look at, it appears as, yes, the justification is present like this. Whereas this is plus Me and second one is minus Me, two groups are present. Out of these two groups, the deciding group is plus Me group. All plus Me groups are ortho and para directing groups. Out of presence of two varieties of groups, the deciding group is plus Me. As we know, this plus Me group is ortho and para directing group, whereas the ortho position will becomes very much crowded portion, because it is combination of 1 2 3 4 varieties of groups are present. Hence substitution takes place at the para position, and it results into the formation of the stablest carbocation. Secondary is the stablest. Nearby the secondary, there is no other relatively more stablest possible carbocation is not present. Hence from this formed secondary carbocation, the size of the ring will becomes 6-member. That is also a stable ring system. Thus from the para position to the methyl, because as being it is ortho para directing group, from the para position to this one, for this will becomes the para position. This cation makes a substitution by replacing the hydrogen, as in the Friedel-Crafts alkylation reaction, that results into the formation of 6 and 6. One in them is benzene, other is cyclohexane. Benzene is associated with nitro followed by methoxy, whereas 6-member ring is associated with what? Methyl group. Thus substitution takes place.